Hi everybody. Today we're going to talk about work that I'm doing that's in development with a fantastic colleague, Molly Schauffler at the University of Maine. So I want to put out there that this is still a work in development. It is by no means a set in stone, follow to the, every letter and every word, but I wanted to take the opportunity to share with you a new way or a different way of thinking about how do we start to unpack what it takes to work with data, and how can we think about how to unpack that in strategic and conscious ways that really mirrors how what we know from the literature about how people learn with data and how that learning evolves and deepens over time as it gets more complex and more intricate, the kinds of moves that we can do with data. So again, my name is Kristen Hunter-Thompson. Reach out if you have any questions. So what I want us to think about as we're unpacking what it takes to work with data is that we can think about different categories. And first, we've talked a little bit about the difference between exploratory data analysis and explanatory data analysis, or when we're making inferences and claims and communicating with those. So that's one tier of categorization we can make, but we can go another tier down, and we can think about when we're doing exploratory data analysis, what are the things that we're doing? Well, the different categories are we're producing data, we're asking questions, and then answering those questions from the data, we're asking questions of the data, we're processing and organizing our data, and we're creating and iterating visualizations so that we can see and make sense of the data that we have. The kinds of things that we do in explanatory data analysis, or when we move to making claims and inferences, is we're describing and analyzing patterns, we're interpreting those data within the context of the data and of the question at hand, we're making claims and inferences from the data, and we're exploring our certainty in those claims and inferences that we are making. So the way that we have this organized is each of those subcategories will be on a slide, and we've identified different tasks or skills that students can do with regards to that category. So that category in and of itself has multiple components that are involved. And so each of those multiple components will have its own cell within these tables. And then across the tables, what we've done is we've identified sort of across these different grade chunks or grade bands or grades, what are the skills based on current research from learning sciences, statistical literacy, data visualization, perception science, a wide variety of different research that is out there about how people learn, as well as some prominent standards that we're using in our teaching. So next generation science standards, Common Core math, various state social studies standards. So using things like that to determine kind of where are students doing what when it comes to working with data. And you'll notice that we have both grade bands listed, as well as we've identified it as sort of steps through. And that's because while this is what the standards or the research might tell us about what students are capable of at different grade levels, the reality is that if your students haven't mastered or haven't built their mastery in skills in a previous grade band, then you can't start tackling what it is that you're working on in your grade band, because this is the evolution of the skills. So another way to think about that is just because something's identified in grade 3-5 doesn't mean you can't accomplish also and reinforce and reiterate and have your students practice the skills that are listed in a previous step, say grades K-2. So we can look at this as a resource. Molly and I are building this out as a resource so that as educators, we can get a sense of, okay, sort of, here is my grade level. I am a 6th grade science teacher. What are things that I should be focusing on for my students? So you can read vertically down one of these tables within the different categories, but also kind of where does that fit into the broader context of like, what should I make sure my students have an understanding and an ability to accomplish before I start diving into those 6th grade math skills by looking at what our colleagues worked on previously, and also where is that boundary? Where is the limit of where I need to take my students so that they're prepared going forward? So getting a sense of kind of what our colleagues will pick up and take forward as they move forward. So we can look across these tables both horizontally as well as vertically. And again, just a reminder that this is work that's in development. So it is meant to spark conversation and get some ideas flowing, but not to be taken as like the absolute truth. So let's dive in. So when we come to thinking about producing data, this involves things such as physically collecting your own data, as well as using data that somebody else has collected. It incorporates the skills that we need in terms of what units we're doing. So be that relative units for our younger students, or understanding of what the actual units are as our students progress. It also incorporates an understanding of what is our sample and what is the full population. And so that we can get a sense of, does the data we have reasonably represent that larger population? The other component of producing data is an understanding of, are we collecting and looking at observational data for an observational investigation where we're describing the phenomenon or the system? Or are we collecting data that is from a simple experiment where we have a control and a treatment or multiple treatments, and we're looking for differences among those? The next category are asking questions. So this involves thinking about, how do we move from one of these big picture science questions into something that's actually testable, that we can use data to answer. And this also gets a little bit at thinking of, sort of, as we form those questions that we want to answer with data, starting to make some predictions and thinking about what the data might look like with regards to our question. When it comes to processing and organizing data, there are various components included in this. One of the big ones being, how do we record observations that we're making, be it from a pre-made table to moving into developing our own hand-drawn table or creating our own digital spreadsheets to capture all of that information. It also factors in things like being able to understand what those different components are of the spreadsheet, so that when we design the spreadsheet, we know how to organize it into a wide or a long format to help us best answer our question. And because of that, this category also includes that understanding that data points are actual values, and that each observation or each membership is a case of data, and therefore should have its own row representing those data within our data table or within our digital spreadsheets. And then finally, the last category for exploratory data analysis are creating and iterating visualizations. So in this, this category includes both the use, so being able to read and interpret, as well as being able to create ourselves these different data representations, and how those data representations grows and builds over time, in terms of we're continuing to use different visualizations that we've learned previously, but we're also building and adding different data visualizations, different kinds of graphs and maps that we can use as we move forward and are able to ask more complex questions of data. Also within this is building that sense of what data visualization or what graph or map that I use is dependent upon what the question is and what kind of data I have, as well as that drives what variables or attributes we put where within our graphs and our maps. So switching over to the categories that fall into the explanatory data analysis or the making meaning, we can think of the first big thing is that we have to describe and analyze the patterns that we see. And this moves from students making these descriptions in terms of relative quantities and making informal comparisons, to building out to be more specific and describing things using, with the use of summary statistics like different measurements of center, or recognizing whether a scatter plot is linear or nonlinear, different things like that. So we build in the quantitative complexity of how we describe and analyze the patterns. And we also think about, are we describing quantities? Are we describing similarities and differences? Are we comparing and contrasting? Different things like that. So this all falls into the describing and analyzing, like what are we actually seeing within the patterns? And then from there, we can move into interpreting it and thinking about sort of what this means overall and what this means with regards to the context with which the data were collected. So we're comparing patterns to our prediction, we're making informal conclusions that we're moving to be more qualitative descriptions and more specific descriptions. We start using sort of mathematical quantitative concepts like slope and approximating the probability that the pattern occurred by chance versus due to anything that you have done, different things like that. And again, we're thinking about, we're comparing different variables, or we're comparing aggregate properties of a group or among categories, things like that. But this step is taking us to like, so what does that actually mean from what we've seen in the data? So that we can actually make our claims and our inferences. And so we've moved from making sort of informal statements to writing out full claims about what's going on in the data and what it means in relation to our original question. We build in complexity in terms of what kind of information we include within our reasoning and what evidence we draw from our graph to be our reasoning, to support our reasoning of why that evidence supports that claims. And we circle back to, if this is our sample, therefore what can we say? What inference can we draw about the whole population from the data that we have in the sample? And another important component of that in science is thinking about understanding a sort of just how certain we can be from our data. So this thinks about potential factors that could limit how sure we are in making claims. It gets us to start thinking about, well, just how confident are we in that claim with regards to our question based on the data that we have. And this circles back to, okay, well, so we thought about our accuracy and precision as we were producing data. Now we have to revisit that and think about how that influences what claims we can make from the data. So this was a broad brush through draft work that Molly and I are putting together, but hopefully it sparked some ideas and some thinking about how to unpack and break down these different components of how to work with data, and how you can think about starting to share that with your students as you go forward into, as you're teaching your students with data and how to make sense of the world with data. As always, reach out if you have any questions, and I'm happy to help. Thank you. Have a good day.